Hi everybody, I'm going to explain the Young's single and double slit interference. First of all, what is interference? The word interference means combination of two or more electromagnetic waveform to form a resultant wave in which the displacement is either reinforced or cancelled. Young's double slit experiment demonstrates that light can display characteristics of both wave and a particle. Let us move on to the aim of the experiment. The aim of the experiment is to observe the character of the single slit diffraction and to observe the character of the double slit diffraction. Basically, diffraction is the process by which a beam of light or a wave spread out as a result of passing through a narrow aperture which further forms interference at the end. This is used to demonstrate our experiment of Young's double slit and single slit interference. For this, we need a helium neon laser, a slide of single slit, a slide of double slit, slit holders, and a meter stick. Let us move on to the formula. The interference of the light through the single slit is measured by A sin theta 1, which is equal to m lambda. Here, sin theta 1 is equal to L1 divided by L, where A is a slit width, m is the order of the fringe, L1 depicts the distance between the two minima of order m, and L denotes the distance between the screen and the slit. On the other hand, the interference of the light through double slit is calculated using d sin theta 2, which is equal to m dash lambda. Here, sin theta 2, which is equal to L2 by L, where d is the slit separation and L2 is the distance between the central maximum and the minimum of order m. For better understanding of maxima and minima, let us view this image. The area with the bright fringe is the central maximum, and the dimmer region beyond that depict the first order minimum and second order minimum respectively. Now let us move on to the description. The experimental setup must be placed such that the laser is placed at one end of the optical bench and the single slit holder about 5 cm from the laser. Cover the screen with a paper and place it in the other end. Select the slit whether single or double and adjust its position to the left, right, up and down until the beam is centered on the slit. Let's move on to the procedure for the single slit interference. First of all, this single slit interference brings out the wave property of the light. For this, we need to turn on the laser source and place the single slit before it using a slit holder. Measure the distance between the single slit and the screen. You will be able to see the bright and the dark fringe patterns in the screen. Turn off the lights and mark the position of the minima in the diffraction pattern. Then turn on the lights and now measure the distance between the first order marks, that is m is equal to 1, and the second order marks, that is m is equal to 2. Now record these readings in the observation table. We need to note the order of the fringe, the distance between the two minima, that is L dash, the distance from the center to the side, that is L1, measured using L dash by 2, and we need to calculate sin theta 1, which is equal to L1 divided by L. Finally, substituting these values in the formula A is equal to m lambda divided by sin theta 1, we get the value of A, that is the slit width. In my case, in the observation table of determination of single slit, I am getting the value as 0.63 into 10 power minus 5. The value of A must be more or less same in both the cases, that is M1 and M2. As it slightly varies in my case, I take the higher values. Thus, the slit width of the single slit interference is 0.63 into 10 power minus 5. Now let us see the procedure for double slit interference. Turn on the laser same as the single slit, determine the distance from the slit to the screen and record the screen positions. Turn off the lights and mark the first and second order marks. Note that the slits are offset from the center line of the slit holder. Divide the distance between the side orders and obtain the distance from the center of the fringe pattern to first and second order maxima. Then record these in the observation table. In the observation table for the determination of slit width and slit separation for double slit interference and diffraction, you need to note the distance from the screen to the slit, and in the table you need to note the order of the fringe and the order of the fringe m dash, distance between the two minima of order m, that is L1, distance between the central maximum and the minimum of order m dash, which is denoted by L2. And using these, find sine theta 1 and sine theta 2 and substitute those in A is equal to m lambda divided by sine theta 1 and D is equal to m dash lambda divided by sine theta 2 to get the values of A and D. In my case, the distance between the screen to the slit is 0.67 meters. And in the order of the fringe is m is equal to 1 and m dash is equal to 1 and L1 is equal to 0.05. Similarly, L2 is equal to 0.005, and I substitute these values in sine theta 1 and sine theta 2, and finally in the formula for A and D, I get the value of D as 0.84 and 0.85. As I said before, the value of A and D must be more or less same in both the cases m is equal to 1 and 2. So approximating these values, I take the values as 0.8. So my slit width for the double slit diffraction is 0.8 into 10 power minus 5. In this way, we can find the slit width of the single and the double slit. This is Young's singles and double slit experiment. Thank you. This is Karthika signing off.